For each scaling type listed below the table, drag it to the appropriate boxes in the correct match column to match it against its description in the option column. Option, add more CPU to a virtual machine. Correct match, vertical scaling. Add more servers to balance load. Correct match, horizontal scaling. Increase RAM on a server. Correct match, vertical scaling. Deploy additional virtual machines. Correct match, horizontal scaling. Reduce the number of servers. Correct match, horizontal scaling. Now let's explain these answers in detail so everything makes perfect sense. Starting with add more CPU to a virtual machine, this is a clear example of vertical scaling because you're increasing the capacity of an existing server rather than adding more servers. Similarly, increase RAM on a server also aligns with vertical scaling since you're boosting internal resources on a single machine. On the other hand, add more servers to balance load falls under horizontal scaling because you're distributing traffic or processing across multiple servers. This improves fault tolerance and performance by spreading the load. Next, deploy additional virtual machines is another instance of horizontal scaling. Instead of upgrading a single server, you're deploying more virtual machines to share the workload. Finally, reduce the number of servers still fits under horizontal scaling. In this case, you're scaling in, which means removing instances or servers as demand drops, maintaining cost efficiency. So remember, vertical scaling upgrades an individual server, while horizontal scaling adds or removes servers to adjust to demand. Indicate whether the following statements are true or false. Performance predictability is the ability to forecast the resources needed to maintain optimal application performance. Answer: true. Cost predictability means that resource use and costs can be accurately tracked and forecasted in the cloud. Answer: true. The Azure well-architected framework provides no guidance on cost management or performance optimization. Answer: false. Vertical scaling is more cost-effective than horizontal scaling in most cases. Answer: false. Now let's go ahead and explain why each of these answers is correct. To begin with, performance predictability being true makes perfect sense. It's all about estimating the right amount of computing resources to ensure consistent and satisfactory application performance. This helps avoid both underperformance and over-provisioning. Moving on, cost predictability is also true because cloud platforms like Azure provide tools and metrics that help track usage and forecast spending. This is essential for budgeting and managing expenses effectively in a cloud environment. However, the statement about the Azure well-architected framework is false. This framework indeed provides detailed guidance on various pillars, including cost optimization and performance efficiency. It's specifically designed to help architects make better decisions in cloud environments. Lastly, the idea that vertical scaling is more cost-effective than horizontal scaling is incorrect. Horizontal scaling often proves more cost-effective in the long run because it provides better fault tolerance and scalability. Vertical scaling may hit hardware limits and can become expensive as resource demands increase. In real-world scenarios, organizations often adopt a combination of both, but horizontal scaling gives more flexibility when designing scalable cloud systems. For each statement below, indicate whether the answer is true or false. Cloud reliability refers to the ability of a system to recover from failures and continue functioning. Answer: true. Cloud reliability is enhanced through a decentralized infrastructure with global deployment. Answer: true. If one cloud region fails, all applications in that cloud service automatically go offline. Answer: false. Cloud providers do not offer any built-in features to improve reliability. Answer: false. All right, let's break it down so you fully understand each one of these. First, when we say cloud reliability refers to the ability of a system to recover from failures and continue functioning, that's absolutely true. A reliable system should be able to bounce back and keep operating with minimal disruption, even if something breaks. Secondly, the statement that cloud reliability is enhanced through a decentralized infrastructure with global deployment is also true. Cloud platforms like Microsoft Azure and AWS spread resources across various regions globally, so workloads can fail over at other locations when necessary. Now, the idea that if one cloud region fails, All applications in that cloud service automatically go offline is false. Most cloud services are architected with regional redundancy, so a failure in one region doesn't mean your entire application will crash. Services are built to route around trouble. Lastly, the claim that cloud providers do not offer any built-in features to improve reliability is clearly false. Cloud platforms provide several features like automatic failover, backup and restore options, load balancing, and multi-region deployment, all designed to improve uptime and resilience. So in a nutshell, cloud reliability is all about keeping things running smoothly even when things go wrong. And the cloud is built with exactly that goal in mind. For each statement below, indicate whether the answer is true or false. PaaS provides a fully managed cloud environment where users only focus on deploying and managing applications. Answer: true. In a PaaS model, users must manually install and update the operating system and development tools. Answer: false. PaaS is commonly used for developing and hosting applications without managing the underlying infrastructure. Answer: true PaaS requires organizations to handle all network security and connectivity configurations. Answer: false. Let's now walk through these statements one at a time to clarify the answers. First, it's absolutely true that PaaS provides a fully managed environment. This means developers don't need to worry about setting up hardware or maintaining the operating system. They can just focus on writing and deploying code. For example, services like Azure App Service or Google App Engine handle all the background setup for you. Next, the idea that users must install and update the OS and development tools in a PaaS model is false. One of the biggest advantages of PaaS is that the provider takes care of those foundational tasks. You don't have to worry about updates or patches, they're handled behind the scenes. Moving on, it's true that PaaS is commonly used for developing and hosting applications. Developers get access to scalable infrastructure and ready-to-use frameworks without managing servers, which speeds up deployment and improves productivity. Lastly, the statement that PaaS requires organizations to manage all network security and connectivity is false. While developers might configure some aspects, the cloud provider still manages many layers of security like encryption, network segmentation, and threat protection. In essence, PaaS simplifies development by offloading infrastructure concerns to the provider, allowing you to focus on innovation and code delivery. Fill in the blanks by selecting the correct options from the drop-down menus. In the shared responsibility model for SaaS, the cloud provider is responsible for application maintenance, while the consumer is responsible for data security. Now let's take a moment to explain what this means and why it's correct. In a software as a service SaaS model, the cloud provider handles nearly everything behind the scenes. That includes maintaining the servers, the network, and even the application itself. A common example would be Microsoft 365 or Google Workspace. Users don't install or update the app. It's all managed by the provider. However, the consumer or end user still plays a key role. They are responsible for the data they input into the service. That includes setting strong passwords, managing user permissions, and ensuring sensitive information is handled securely. So, while the provider keeps the app up and running, the consumer must take steps to protect their own data within it. This division of responsibility helps maintain security and efficiency in the cloud. Contoso hosts a legacy CRM application that runs on an Azure VM scale set. The application runs at a steady state of around 30% resource utilization. However, during month-end closing activities, the application spikes to 90% resource utilization for extended periods during the last week of the month. Azure allows Contoso IT to meet these spikes in resource demand at the push of a button, paying for the additional capacity only when needed. This is an example of select one answer. A, scalability, B, elasticity, C, fault tolerance, D, high availability. Correct answer, B, elasticity. Now let's break this down and explain why elasticity is the right choice. Elasticity refers to the ability of a system to automatically or dynamically adjust resources, either scaling them up or down based on real-time demand. In this case, Contoso's system sees predictable spikes at month end, and Azure helps meet that need on demand without overpaying when usage is low. That's elasticity in action. Scalability, while similar, focuses more on a system's capability to handle growth over time, such as designing an app that can support more users as a business expands. Elasticity, however, emphasizes short-term responsiveness to workload changes. Fault tolerance deals with maintaining operations during hardware or software failures, which isn't the issue described here. Similarly, high availability ensures systems are accessible without downtime, but it doesn't directly address the ability to adjust to fluctuating workloads. So in practical terms, elasticity means Contoso pays only for what it uses, scaling up when needed and scaling back when it's not. What are cloud-based backup services, data replication, and geo-distribution features of? Select only one answer. A cost reduction plan. B, a disaster recovery plan. C, a hybrid cloud deployment. D, an elastic application configuration. Correct answer, B, a disaster recovery plan. Now let's walk through the reasoning behind this choice. Cloud-based backup, data replication, and geo-distribution are all tools designed to keep data safe and recoverable in case something goes wrong. That's exactly what a disaster recovery plan is meant to do. It's a strategy that ensures business continuity even during system failures, outages, or natural disasters. On the other hand, a cost reduction plan focuses on minimizing spending. While disaster recovery might indirectly reduce losses, its main goal isn't about saving costs, it's about protecting operations. A hybrid cloud deployment involves combining on-premises infrastructure with cloud resources. Although it might use replication or backup, it's not the specific purpose of those features. Lastly, elastic application configuration is all about adjusting computing resources up or down in response to demand, which is more about performance and efficiency than backup or recovery. So, in any resilient cloud strategy, features like geo-distribution and replication clearly support a disaster recovery plan, making that the correct and best fitting answer. Which of the following is a benefit of cloud scalability? Select one answer. A, you can run multiple versions of your application simultaneously. B, resources can be adjusted dynamically to meet fluctuating demand. C, you are guaranteed 100% uptime for your application. D, data backups are automatically created and stored in different regions. Correct answer, B, resources can be adjusted dynamically to meet fluctuating demand. Now let's walk through the reasoning behind this answer. Scalability is all about the ability to grow or shrink your cloud resources based on demand. If your application suddenly experiences a surge in traffic, scalable cloud infrastructure lets you add more resources to maintain performance. Then, when demand drops, you scale back to save costs. This dynamic flexibility is what makes scalability such a powerful cloud feature. Option A, running multiple versions of your application, relates more to testing or redundancy than to scalability. You might do this in a DevOps or CI/CD context, but it's not the primary benefit of scalable infrastructure. Option C, a guarantee of 100% uptime, is unrealistic. No cloud provider can offer absolute uptime. Even with scalability, there's always the possibility of planned maintenance or unexpected outages. Finally, option D, automated data backups and geo-redundancy, is a great feature but falls under disaster recovery, not scalability. So in summary, the key benefit of cloud scalability is its ability to match resource allocation to real-time demand, helping organizations stay responsive and cost-efficient. Your business is growing, and you need to ensure your computing resources can meet an increased workload without purchasing additional physical hardware. What solution would best fit this scenario? Select one answer. A, purchase more physical servers. B, use cloud computing to add compute power as needed. C, reduce the workload to fit existing hardware. D, hire more IT staff to manage the existing servers. Correct answer. B, use cloud computing to add compute power as needed. Let's now explain why this is the most suitable solution. Cloud computing provides the ability to scale resources on demand, which means you can instantly add compute power when your business needs grow without buying new physical servers. This makes it both flexible and cost-effective. For instance, services like Azure Virtual Machines or AWS EC2 let you scale up or down based on real-time workload. Now, purchasing more physical servers, as mentioned in option A, would not only be expensive, but also time-consuming and less flexible. You'd have to deal with setup, maintenance, and long-term depreciation. Option C, reducing the workload to fit your existing hardware, goes against the idea of business growth. It limits your capacity rather than expanding it, which could affect performance or customer experience. Option D, hiring more IT staff might help manage your systems better, but it doesn't solve the core issue. You still wouldn't have the compute power needed to handle the increased load. So ultimately, using cloud computing to add compute power on demand is the smartest and most efficient choice for growing businesses. For each Azure Virtual Network configuration step listed below the table, drag it to the appropriate boxes in the correct match column to match it against its description in the option column. Each item may be used once, more than once, or not at all. Defines the private IP range available for the virtual network. Address space, a segment within a virtual network that organizes resources. Subnet, a virtual machine must be deployed in the same region as its assigned VNet. Regional binding provides secure remote access to a VM with no public IP. Azure Bastion. Now let's go over each match and explain how it works in a real Azure setup. Starting with the address space, this refers to the block of private IP addresses you assign to a virtual network. It's like setting the boundaries of a neighborhood before building the houses. Everything inside your VNet will pull from this IP range. Next is the subnet. Think of it as dividing that neighborhood into streets. A subnet breaks the virtual network into smaller, manageable parts. This helps you isolate resources, control traffic, and apply different security rules to different workloads. Now, regional binding means that your virtual machine must live in the same region as the virtual network it's part of. Azure doesn't support cross-region VNets for VMs, so if your VNet is in West Europe, your VM must also be in West Europe. Finally, Azure Bastion provides a way to securely access virtual machines without assigning them public IP addresses. It allows you to connect via RDP or SSH directly through the Azure portal, reducing your exposure to external threats. Each of these plays a crucial role in how you configure and secure your network in Azure. Fill in the blanks by selecting the correct options from the drop-down menus. The parameter settings in the AZ-VM extension set command specifies the URL of the script to be run on the VM. Let's now walk through the explanation so you understand how all these parts fit together. When you're using the Azure CLI to automate configurations on a virtual machine, the AZ-VM extension set command allows you to add or update extensions. These extensions can include scripts that install software or configure settings. Now, the /settings parameter plays a key role because it tells the system where to find the configuration details, more specifically, the URL pointing to a script or a JSON file that contains the necessary settings. For example, if you want a custom script to run on your VM right after deployment, you'd use -settings to pass the URL of that script. This way, the command knows exactly what to execute and where to fetch it from. Altogether, this setup helps automate tasks and streamline VM customization without manual intervention. That's why understanding this command structure is so important in Azure administration. For each statement below, indicate whether the answer is true or false. Azure ExpressRoute provides a private connection between an on-premises network and Microsoft Cloud services. True. ExpressRoute connections always travel over the public internet. False. Each location that uses ExpressRoute requires its own ExpressRoute circuit. True. ExpressRoute is only used for connecting on-premises data centers to Azure and cannot connect different on-premises sites. False. Let's now walk through these statements to understand why these answers are correct. First, Azure ExpressRoute does provide a private, dedicated connection between your on-premises infrastructure and Microsoft's cloud. This avoids the public internet, offering higher security, more reliable bandwidth, and better performance. Next, it's false that ExpressRoute connections always travel over the public internet. In fact, they never do. Instead, they use a private connection via a connectivity provider, making them ideal for sensitive or mission-critical workloads. Now, when it says each location needs its own express route circuit, that's true. If you have offices in different physical locations, each one must establish its own circuit to connect securely with Azure, unless you're using advanced routing features. Finally, it's incorrect to say ExpressRoute cannot connect different on-premises sites. Thanks to a feature called ExpressRoute Global Reach, you can link multiple on-prem sites through interconnected circuits, enabling private communication across your organization without touching the public internet. So overall, ExpressRoute is about private, high-performance, enterprise-grade connectivity that stays off the internet for both cloud and inter-office communications. For each Azure Compute option listed below the table, drag it to the appropriate boxes in the correct match column to match it against its use case in the option column. Infrastructure as a service for hosting and scaling VMs, Azure Virtual Machines, VMs, orchestrates containers with Kubernetes for complex apps. Azure Kubernetes Service, AKS, provides a cloud-based virtual desktop and app experience. Azure Virtual Desktop, AVD, ideal for running full operating systems on virtual hardware. Azure Virtual Machines, VMs, enables remote work with virtualized desktops. Azure Virtual Desktop, AVD, manages and scales containerized applications. Azure Kubernetes Services. Let's go ahead and explain how each of these matches up to the right Azure Compute solution. Starting with Azure Virtual Machines, this service gives you full control over the OS and applications on virtualized hardware. It's perfect when you need a traditional infrastructure as a service setup or want to run full operating systems just like on a physical server. Next, Azure Kubernetes Service, or AKS, is Microsoft's managed Kubernetes platform. It handles orchestration of containers, scaling across clusters, and simplifies deploying complex containerized apps without needing to manage Kubernetes manually. Now, when it comes to Azure Virtual Desktop, it's designed for remote work scenarios. It allows users to access virtual desktops and apps from anywhere, securely hosted on Azure infrastructure. That's why it fits both providing cloud-based desktop experiences and enabling virtualized desktop access for remote teams. Finally, AKS comes into play again for managing and scaling containerized applications. It automates tasks like health monitoring, updates, and load balancing across containers, making it essential for modern cloud-native apps. In short, each compute option in Azure has a clear and specific purpose depending on whether you're working with VMs, containers, or remote desktop environments. For each Azure infrastructure component listed below the table, drag it to the appropriate boxes in the correct match column to match it against its feature type in the option column. Virtual machines pinned to a specific zone, zonal services. Automatic replication across zones, zone redundant services. Manage disks located within a zone, zonal services. SQL databases with automatic replication across zones. Zone redundant services, IP addresses assigned to specific zones, zonal services. Let's take a moment to explain why each of these is matched correctly. Starting with virtual machines pinned to a specific zone, this clearly falls under zonal services. The VM is deployed into a particular availability zone, giving you control over where your resources live for better latency or compliance. Next, automatic replication across zones is a hallmark of zone redundant services. These services are designed to provide high availability by replicating data or resources across multiple zones, protecting against single zone failures. Now, managed disks located within a zone also match zonal services. These disks are tied to the zone where the virtual machine is deployed and don't replicate across zones unless explicitly configured with redundancy. Similarly, SQL databases with automatic replication across zones are a feature of zone redundant services. This ensures your database remains available even if one zone experiences an outage. Lastly, IP addresses assigned to specific zones belong to zonal services because they're tied to the physical location of the resources they're assigned to, like a VM in Zone 1 or Zone 2. In short, zonal services are tied to one zone, while zone redundant services spread across zones to increase resilience. Indicate whether the following statements are true or false. Microsoft Entra ID allows developers to integrate single sign-on (SSO) functionality into their apps. True. Microsoft Entra Connect performs two-way synchronization between on-premises AD and Microsoft Entra ID. False. Microsoft Entra Domain Services allows legacy applications to use modern authentication protocols. True. Multi-factor authentication, MFA, requires only one factor of identification during the sign-in process. False. Let's take a moment to break down each statement for clarity. First, it is true that Microsoft Entra ID enables developers to implement SSO. This means users can sign in once and access multiple apps without being prompted again, which improves both security and user experience. Next, the claim that Entra Connect supports two-way synchronization is false. Entra Connect only syncs one way, from on-premises Active Directory to Microsoft Entra ID. Any updates in Entra ID do not flow back to the local AD. Then, we have Entra Domain Services, which is true in this context. It allows legacy applications that rely on traditional protocols like LDAP or Kerberos to work with cloud identities, even though those applications may not support modern auth protocols like OAuth. Finally, the idea that MFA requires only one factor is false. The whole point of multi-factor authentication is that it requires at least two different types of verification, such as a password and a fingerprint, to strengthen identity security. So overall, understanding how these Entra components work helps in designing more secure and user-friendly identity solutions in Azure. Determine if the following statements are true or false. Azure functions require users to maintain virtual machines or containers for execution. False. Azure App Service supports automatic scaling for web applications based on traffic demand. True. Azure Virtual Networks can connect resources in different regions via peering. True. Azure Web Jobs can run background jobs in the same environment as web apps and APIs in Azure App Service. True. Let's now walk through the explanation behind each of these answers. Starting with Azure Functions, it's false that users need to maintain virtual machines or containers. Azure Functions are serverless, which means Microsoft handles all the infrastructure behind the scenes, allowing you to focus purely on writing code that runs in response to events. Next, Azure App Service does support automatic scaling, which is true. This means if your web app sees a spike in traffic, Azure can automatically increase the number of instances to handle the load, helping maintain performance without manual intervention. Moving on, it is true that Azure Virtual Networks can connect resources across different regions using virtual network peering. This feature allows seamless communication between VMs or services in different regional VNets, useful for global applications. Lastly, Azure Web Jobs can indeed run background tasks in the same environment as your web apps and APIs in Azure App Service, making this true. It's a practical option for processing tasks like file cleanups, queue processing, or scheduled operations alongside your app logic. So, as you can see, each feature is designed to simplify development and scalability while reducing infrastructure overhead. For each statement below, indicate whether the answer is true or false. Azure Management Groups provide a way to apply governance policies across multiple subscriptions. True. Management groups can be nested to create a structured hierarchy. True. A subscription can belong to multiple management groups at the same time. False. Policies applied at the management group level are inherited by all subscriptions and resources underneath it. Now let's go through each of these one by one to clarify the reasoning. First, it is absolutely true that Azure Management Groups allow you to apply governance policies like security and compliance rules across multiple subscriptions. This helps large organizations maintain control from the top level down. Second, management groups can be nested, and that's also true. You can create a structured hierarchy up to 6 levels deep, allowing for better organization of departments, teams, or business units. However, the idea that a subscription can belong to multiple management groups at once is false. A subscription can only be associated with one management group at a time, which keeps policy application clear and avoids conflicts. Lastly, policies set at the management group level are inherited by every subscription and resource beneath it, which is true. This means once a rule is applied to a management group, all child resources automatically follow that rule, making it easier to enforce governance at scale. In essence, Management groups are your top-level structure for controlling resources in a consistent and centralized way. For each statement below, indicate whether the answer is true or false. Defense in depth ensures that if one security layer is breached, other layers remain in place to prevent further damage. True. The network security layer is only responsible for preventing external threats, not internal threats. False. Identity and access management includes setting up role-based access control RBAC to restrict user permissions. True encryption is a key feature of the data security layer.
True.
Now let's walk through these one at a time and explain what makes each statement correct or incorrect. Starting with defense in depth, that statement is true. This is a strategy that uses multiple layers of security, such as firewalls, encryption, access controls, and monitoring. If one layer fails, the others still help protect the system. It's all about redundancy and resilience. Next, the statement about the network security layer is false. While it definitely protects against external threats like DDoS attacks, it also plays a crucial role in detecting and blocking internal threats, such as lateral movement by attackers who've breached initial defenses. Then we have identity and access management, and yes, this is true. RBAC is a critical part of IAM. It allows you to assign users specific permissions based on their role, helping you follow the principle of least privilege and reduce the risk of accidental or malicious access. Finally, encryption, being a key part of the data security layer, is also true. Encryption protects sensitive data both while it's stored and while it's being transferred, preventing unauthorized access even if the data is intercepted. So, in summary, these layers work together to build a strong, secure cloud environment. For each statement below, indicate whether the answer is true or false. Microsoft Entra Domain Services eliminates the need for deploying, managing, and patching domain controllers. True. Microsoft Entra Domain Services does not support Kerberos and NTLM authentication. False. Microsoft Entra Domain Services is synchronized one way from Microsoft Entra ID. True. Microsoft Entra Domain Services is required for all applications running in Azure. False. Now let's walk through the explanation of these statements one by one. The first statement is true. Microsoft Entra Domain Services offers managed domain services like LDAP, Kerberos, and Domain Join without the need for you to deploy or manage your own domain controllers. This is especially helpful for moving legacy apps to the cloud. Next, the statement saying Entra Domain Services does not support Kerberos and NTLM is false. In fact, it does support both. That's one of its biggest benefits, allowing legacy authentication methods to continue functioning in a cloud-first environment. Then, the idea that synchronization is one way from Microsoft Entra ID is true. Identity data flows from Entra ID into Entra Domain Services, but not the other way around. Any changes made in the managed domain stay there, they don't sync back. Finally, the claim that Entra Domain Services is required for all Azure applications is false. Not all apps need traditional domain services. It's only necessary for apps that depend on domain join or legacy protocols like LDAP. So in summary, Microsoft Entra Domain Services helps bridge the gap for legacy apps in the cloud without adding the overhead of maintaining domain infrastructure. An Azure user seeks a fully managed SQL Server instance hosted by Microsoft as a PaaS service. How does Azure SQL Managed Instance enable the user to migrate new applications to the cloud without significant application changes? A. By offering frictionless lift and shift scenarios. Correct. B. By offering full isolation and security. C. By offering a PaaS solution that focuses solely on databases and data. D. By offering elastic databases and data pools rules. Let's walk through the explanation behind this answer. The correct choice is A, because Azure SQL Managed Instance provides near 100% compatibility with SQL Server on premises. This makes it ideal for lift and shift migrations, meaning you can move your applications to the cloud without needing to rewrite or reconfigure them extensively. It's one of the key benefits that sets SQL Managed Instance apart from other SQL services. Option B, although Azure SQL Managed Instance does include security and isolation, that's not the main reason it's helpful for easy migrations. The focus here is on compatibility, not isolation. Option C is a bit misleading. While it is a PaaS service and works with databases and data, its key strength is enabling application migrations, not simply being a database platform. Option D refers to features in Azure SQL database, not SQL managed instance. Elastic pools help optimize cost, but they aren't the solution for migrating full applications without changes. So overall, Azure SQL Managed Instance makes migrations easy by mimicking the environment of an on-prem SQL server, giving users a seamless path to the cloud. How does Azure Synapse Analytics deliver end-to-end analytics at cloud scale? Select one answer. A. It stores petabytes of data and runs queries on relational and non-relational data. Correct. B. It stores terabytes of data and performs in-depth drilling to provide data insights. C. It uses functions in two modes, data storage and data analytics. D. It provisions clusters with multiple services to perform a specific task efficiently. Let's break this down and explain why option A is the correct answer. Azure Synapse Analytics is a powerful cloud-scale analytics service that allows you to work with petabytes of data, not just terabytes. That makes option B incorrect right away. It's not limited to small-scale datasets. Instead, Synapse integrates big data and data warehousing capabilities to run complex queries across both relational and non-relational sources at massive scale, which is what makes A the most accurate. As for option C, it oversimplifies how Synapse works. While it supports storage and analytics, the platform offers much more, like integrated machine learning, pipelines, and Spark, not just two isolated functions. And regarding option D, yes, clusters may be used in the background, but provisioning clusters isn't the defining feature of Synapse. Its real strength lies in offering a unified analytics experience that scales and integrates with other Azure services. So when thinking about Synapse, think big. Petabytes of data, hybrid query capabilities, and a single platform for data exploration, transformation, and insight. Arrange the steps involved in securing an Azure Storage account with a private endpoint in the correct sequence. 1. Create an Azure Storage account. 2. Deploy an Azure Virtual Network, VNet. 3. Create a private endpoint within the VNet. 4. Configure the storage account to disable public access. 5. Verify private connectivity using a VM in the VNet. Let's go ahead and explain why this order is correct. We start with creating the Azure Storage account because you need a storage resource before you can secure it or attach any networking configurations to it. Without the storage account, there's nothing to protect. Next, we deploy a virtual network, or VNet. This is essential because a private endpoint can only exist within a VNet. The VNet serves as the private communication channel. After that, we create a private endpoint within the VNet. This step links the storage account to the VNet using a private IP, allowing secure internal-only access to your storage. Then, we configure the storage account to disable public access. This is what locks it down so it's no longer reachable from the public internet, ensuring all traffic flows through the private endpoint. Finally, you verify private connectivity using a virtual machine in the VNet. This VM is used to test and confirm that the storage account is accessible only via the private endpoint, completing the secure setup. Following this sequence ensures your storage account is properly isolated and only accessible through your internal network. Arrange the following Azure Blob Storage tiers in order from the most expensive to the least expensive. 1. Hot tier. 2. Cool tier. 3. Cold tier. 4. Archive tier. Let's go ahead and explain why this is the correct order. We start with the hot tier, which is the most expensive because it's optimized for frequent access. Think of data that's constantly being read or updated, like files in active business use. You're paying for low latency and high availability. Next is the cool tier, which is slightly cheaper. This is intended for infrequently accessed data, like monthly reports or backups that you might check every now and then. It costs less to store the data, but slightly more to retrieve it. Then comes the cold tier, which is a newer option and sits between cool and archive. It offers even lower storage costs but has longer minimum retention and access charges. It's ideal for data that must be kept but is rarely accessed. Finally, we have the archive tier, the least expensive of all. This tier is designed for long-term data that you almost never touch, such as compliance records or long-term backups. But the trade-off is that accessing the data requires rehydration, which can take hours. So if you're balancing cost against how often you need access, this tier order helps you plan your storage strategy efficiently. A company needs to automate large-scale data transfers between their on-premises servers and Azure Blob Storage. The solution must allow scripting and execution without requiring a graphical interface. Which Azure tool should they use? Select one answer. A. Azure Storage Explorer. B. Azure PowerShell. C. AsCopy. D. Azure Portal. The correct answer is C. AsCopy. Let me explain why this is the most suitable choice. AsCopy is a command line utility that's specifically optimized for large-scale, high-performance data transfers. It allows for scripting, automation, and scheduling, all without the need for any graphical interface. That makes it perfect for enterprise-scale migrations and backup operations, especially when speed and automation are priorities. Now, although Azure Storage Explorer is helpful for managing storage manually, it relies on a GUI and lacks the automation needed for bulk operations. Likewise, Azure PowerShell can manage storage accounts, but it isn't optimized for high-speed file transfers like AsCopy is. And finally, Azure Portal is purely GUI-based and not built for handling large-scale uploads or scripted automation. So when you want performance, automation, and command line control for big data moves, AsCopy is your go-to tool. Which Azure virtual machine feature staggers updates across VMs based on their update domain and fault domain? Select one answer. A. Availability sets. B. Scale sets. C. Update sets. D. Fault sets. The correct answer is A. Availability sets. Let's go through the availability sets are designed to improve the availability of virtual machines by distributing them across multiple update and fault domains. Update domains help Azure apply updates in a staggered manner, so not all VMs go down for maintenance at once. Fault domains, on the other hand, spread VMs across different physical hardware to reduce the risk of simultaneous hardware failure. Now, while scale sets are useful for automatically scaling VMs based on demand, they don't manage update or fault domains in the same way. As for update sets and fault sets, these are not actual Azure features. Update sets don't exist, and fault sets are often confused with fault domains, which are just a component of availability sets. So in summary, to ensure your VMs stay up during platform maintenance or hardware failures, you want to use availability sets. Which two scenarios are common use cases for Azure Blob Storage? Each correct answer presents a complete solution. A. Hosting ASPX files for a website. B. Mounting a file storage share to be accessed as a virtual drive on multiple virtual machines. C. Serving images or documents directly to a browser. D. Storing data for backup and restore. The correct answer is C. Serving images or documents directly to a browser, and D. Storing data for backup and restore. Let's now explain why these two are the right choices. Azure Blob Storage is optimized for storing unstructured data like images, videos, documents, or logs. So when you need to serve static content directly to a web browser, Blob Storage is ideal. It allows fast and cost-effective access to this kind of data, which is why option C is a perfect fit. Similarly, for backup and restore, Blob Storage shines again. It's scalable, durable, and supports different data formats. Organizations often use it to store long-term backup data or archive infrequently accessed information, which makes D another valid choice. On the other hand, hosting ASPX files, which are part of dynamic web apps, is better suited for services like Azure App Service, not Blob Storage. And mounting a storage share as a virtual drive, that's a use case for Azure Files, not Blob. So, to sum it up, serving static files to a browser and storing backup data are the two classic scenarios for using Azure Blob Storage. You have a mobile application that exchanges large numbers of messages with customer devices. Which type of Azure storage is optimized for storing large numbers of messages and is accessible from anywhere via authenticated HTTP or HTTPS calls? Select one answer. A. Blob storage. B. C. Table storage. D. File storage. The correct answer is B. Queue storage. Now let's walk through the explanation. Queue storage is designed specifically for handling large volumes of messages asynchronously. It allows apps and services to communicate reliably even when components are temporarily offline. It's accessible from anywhere via authenticated HTTP or HTTPS calls, making it perfect for mobile apps that exchange a high number of messages. Meanwhile, blob storage is great for storing unstructured data like images or video files, but it isn't designed for handling message traffic. Similarly, table storage is ideal for structured NoSQL style data, but again, not suited for message queuing. File storage, on the other hand, is used for shared access to files, not for messaging workflows. So if your app relies on sending and receiving lots of messages quickly and reliably, queue storage is the best match. Which of the following statements about Azure storage accounts are correct? Select two answers. Storage account names must be globally unique. Storage accounts support only the block blob storage type. A storage account can contain multiple storage service types, including blobs, tables, and queues. Storage accounts must always be configured with private endpoints. The correct answers are A. Storage account names must be globally unique. C. A storage account can contain multiple storage service types, including blobs, tables, and queues. Let's now break this down together. First, storage account names must be globally unique, because every storage account in Azure gets a unique DNS name. This ensures there's no overlap across the Azure platform and that endpoints are accessible over the internet without conflict. Next, a storage account can contain multiple service types, not just one. Azure storage accounts support blobs, tables, queues, and even files. This allows developers and businesses to manage different types of data, structured, unstructured, and messages, all under one account. On the other hand, the statement about only supporting block blob types is incorrect. Azure supports block, page, and append blobs depending on the workload. And finally, storage accounts do not always have to use private endpoints. Public endpoints are available by default, and private endpoints are optional based on your security or compliance requirements. So if you're choosing the correct statements, A and C are your best picks. Your company is running an enterprise database system that requires high IOPS, low latency, and fast throughput. Cost is not a concern, but performance is critical. Which Azure managed disk type should you use? Select one answer. A. Standard HDD. B. Standard SSD. C. Premium SSD v2D. UltraDisk. Let's go ahead and explain why UltraDisk is the correct choice. UltraDisk is purpose-built for high-performance workloads. It offers up to 64 terabytes of storage per disk, with extremely low latency and exceptionally high throughput. This makes it ideal for enterprise-grade database systems, where performance is the top priority and cost is not a limiting factor. Now, while standard HDD is the most cost-effective option, it's far too slow for performance-critical systems. Similarly, standard SSD is a step up, but it still lacks the high IOPS and ultra-low latency required for advanced workloads. Premium SSD v2 does offer better performance and is suitable for many demanding applications. However, it still doesn't surpass the capabilities of UltraDisk, especially for scenarios where performance is mission critical. So when you need the absolute best disk performance that Azure offers, UltraDisk is the go-to option. For each Azure Cost Management tool listed, drag it to the appropriate box in the correct match column to match it against its purpose. Visualize spending trends, cost analysis, enforce tagging requirements, Azure policy, notify department spending limits, spending quota alerts, set thresholds for resource spending, budget alerts, track costs by resource group, cost analysis, reapply missing tags, Azure policy, notify spending for enterprise agreement EA, spending quota alerts, generate resource spending reports, cost analysis. Now let's take a moment to explain how each tool aligns with its specific function. We'll begin with cost analysis, which is designed to give you visual insight into where your money is going. It helps you visualize spending trends, track costs by resource group, and generate resource spending reports. These features make it a powerful tool for understanding spending patterns over time. Next, Azure Policy is all about governance and compliance. It is used to enforce tagging requirements, ensuring that all resources follow organizational tagging standards. It also helps to reapply missing tags automatically, maintaining consistency across resources. Then we have spending quota alerts, which are notification-based tools. These are ideal for situations where you need to notify department spending limits or alert spending under an enterprise agreement. They are proactive, triggering alerts when thresholds are crossed. Finally, budget alerts allow users to set thresholds for resource spending and receive alerts when approaching or exceeding set limits. This is essential for staying within budget while maintaining operational control. Each tool has a unique focus, and understanding how they interact helps organizations optimize and govern their cloud spending efficiently. For each Azure Monitor component listed, drag it to the appropriate box in the correct match column to match it against its description. Centralized service for monitoring Azure environment, Azure Monitor, performance-based telemetry data, metrics, text-based record of events, logs, captures CPU utilization trends, metrics, stores user activity and resource changes, logs, provides near real-time visibility into system health. Azure Monitor tracks security events and alerts, logs, gathers data from both Azure and non-Azure sources. Azure Monitor. Let's walk through the explanation to understand how each component fits. First, Azure Monitor acts as the central hub. It provides near real-time visibility into system health, gathers data from both Azure and non-Azure resources, and functions as the centralized service for monitoring the entire Azure environment. Think of it as the main console where everything comes together. Now, for logs, these focus on capturing text-based records. They track security events, user activities, and resource changes. For example, when a user modifies a configuration or a security rule is triggered, Azure Monitor logs will capture that information for review or audit. Then we have metrics, which handle performance data. These are numerical time series measurements. They track things like CPU utilization trends or memory usage. These are ideal for performance tuning, troubleshooting, and auto-scaling. Each tool works together to offer comprehensive observability, with Azure Monitor as the orchestrator, logs providing depth, and metrics offering quick performance insights. Fill in the blank by selecting the correct options from the drop-down menu. Azure PowerShell cmdlets call the REST API to manage Azure resources. Let's now go through the explanation. When you use Azure PowerShell, you're essentially working with a set of cmdlets, which are specialized commands designed to interact with Azure services. These cmdlets don't operate independently, they rely on something under the hood. That's where the REST API comes in. Azure's REST API is the backbone for resource management. Every cmdlet you execute in Azure PowerShell translates into an HTTP request to the REST API. For instance, when you run a commandlet to create a virtual machine, that request is sent via the REST API to the Azure backend. So, while you interact with Azure through PowerShell scripts for convenience, all those actions are ultimately powered by the REST API, which communicates with Azure's control plane to provision, manage, or delete resources. In summary, Azure PowerShell acts as a user-friendly layer, and REST API does the heavy lifting in the background. For each statement below, indicate whether the answer is true or false. Bicep is a domain-specific language used to define Azure infrastructure as code. True Bicep files are written in JSON and require PowerShell scripts to execute deployments. False. Bicep simplifies ARM templates by providing a more readable and concise syntax. True Bicep allows users to create modular files for reusable infrastructure components. True. Now, let's go ahead and explain each of these. First, Bicep is indeed a domain-specific language, or DSL, specifically created to simplify Azure infrastructure deployment. It uses a declarative approach, just like ARM templates, but in a much more human-friendly way. Secondly, Bicep files are not written in JSON. This is where many get confused. Instead, Bicep uses its own syntax, which is simpler and more concise. Once written, it gets compiled into ARM-compatible JSON behind the scenes, so you don't need to write JSON manually. Third, the major strength of Bicep lies in how it makes ARM templates easier to read and manage. If you've ever worked with long and complex ARM JSON files, you'll appreciate the clarity Bicep brings. Finally, Bicep supports modular templates, meaning you can break down your infrastructure definitions into smaller, reusable components. This makes your deployments cleaner and much easier to maintain across multiple projects. In short, Bicep helps you write better infrastructure as code without the overhead of raw JSON. For each statement below, indicate whether the answer is true or false. You can manage resource locks using the Azure portal, PowerShell, and Azure CLI. True locks are automatically removed when a resource is deleted. False, a user can modify a locked resource without removing the lock if they have contributor permissions. False, locks must be manually removed before making changes to a locked resource. True. Now let's explain each of these one by one. First, it's true that Azure gives you multiple ways to manage resource locks. You can do this through the Azure portal, PowerShell, Azure CLI, or even Azure Resource Manager templates. So whether you're working through the GUI or scripting, you're covered. Next, a common misconception is that deleting a resource removes the lock automatically. That's false. Azure requires you to remove the lock first before deletion. This adds an important layer of protection to avoid accidental deletions. Now, even if someone has contributor permissions, that doesn't mean they can bypass a lock. Locks override permissions. So to modify a locked resource, even a contributor has to first remove the lock. So that statement is false. Lastly, yes, before you make any changes to a locked resource, that lock must be manually removed. It's a safeguard that prevents unintended updates or deletions, especially in production environments. In summary, locks in Azure are powerful tools for protecting resources, and they must be removed deliberately before any changes can take place. Azure Monitor collects resource and platform data from which of the following data sources? Choose two answers. A. SaaS resources, such as databases and applications. B. On-premises resources. C. IaaS resources, such as virtual desktops, containers, and VMs. D. PaaS resources, such as underlying hardware and infrastructure. Now let's break it down and explain. First, Azure Monitor can indeed collect data from on-premises resources. Using agents like the Azure Monitor Agent or Log Analytics Agent, it can gather logs, metrics, and performance insights from your on-prem servers to give you centralized monitoring, even for hybrid environments. Second, it supports IaaS resources, including virtual machines, containers, and virtual desktops. These are the types of Azure resources where Azure Monitor truly shines, capturing CPU usage, memory, and network metrics with almost real-time accuracy. On the other hand, Azure Monitor doesn't natively collect data from SaaS resources. SaaS applications like Office 365 or Dynamics might require separate integration or APIs to pull that data into Azure Monitor, so option A is incorrect. Finally, although it can monitor PaaS services like app services, it doesn't go as deep as accessing the underlying hardware. That means option D is also incorrect. So the two correct answers are on-premises resources and IaaS resources like virtual desktops, containers, and VMs. A company's chief information officer, CIO, has proposed transitioning virtual machine workloads to a cloud provider to shift from capital expenditure, CapEx, to operational expenditure, OpEx. The CFO, however, is concerned that this may lead to unpredictable OpEx costs. Which pricing option can help the company reduce expenses and make cost forecasting easier? Select one answer. A. Azure reservations. B. Pay-as-you-go. C. Azure VM scale sets. D. Azure in CSP. Let's go ahead and explain why Azure reservations is the right choice. Azure reservations allows businesses to commit to a 1-year or 3-year plan for virtual machine usage. By locking in a longer-term commitment, the organization benefits from significant cost savings and much better cost predictability. This helps the CFO address concerns about fluctuating monthly bills, making budgeting and forecasting a lot easier. Now, pay-as-you-go is great for flexibility, but it's the opposite of predictable. Since charges are based on real-time usage, monthly costs can vary drastically. Azure VM scale sets are excellent for handling workloads that need automatic scaling, but they don't directly solve the CF concern about stable costs. And Azure in CSP, being a reseller program, focuses on procurement and billing flexibility rather than reducing OpEx variability or providing cost predictability. So in this case, the correct answer is definitely Azure reservations, ideal for saving money and staying on top of the budget. Which permission models can be used to manage access permissions for an Azure Key Vault? Choose two answers. A. Vault Access Policy. B. Key Vault Access List. C. Azure Role-Based Access Control. D. Vault-Based Access Control. Now let's explain why Vault Access Policy and Azure Role-Based Access Control are correct. Starting with Vault Access Policy, This is the traditional method used in Azure Key Vault to grant permissions. It allows you to assign very specific rights, like reading a secret or creating a key, to users or applications directly within the Key Vault. Next, Azure Role-Based Access Control is a modern, flexible model that assigns roles through Azure Active Directory. RBAC enables you to manage access at broader scopes, such as the resource group or subscription level, making it ideal for large organizations with complex access needs. On the other hand, Key Vault Access List isn't a valid permission model in Azure Key Vault. It may sound plausible, but it doesn't exist in the platform. Lastly, Vault-Based Access Control is a misleading term. It doesn't refer to any formal Azure Access model. So the correct answer here is a combination of Vault Access Policy and Azure Role-Based Access Control, the two recognized permission models for Azure Key Vault. Which of the following Azure services help enforce Zero Trust security? Select one answer. A. Azure Active Directory, Microsoft Entra ID with conditional access. B. Azure Virtual Network, VRing. C. Azure Blob Storage. D. Azure Cost Management. Now let's explain why the correct answer is Azure Active Directory with conditional access. Zero Trust is a security model that assumes no identity or connection should be trusted automatically. Azure Active Directory, now known as Microsoft Entra ID, paired with conditional access, plays a central role in enforcing this model. It ensures that only verified identities get access, and even then, only to the resources they need. This aligns with the core Zero Trust principles of identity verification and least privilege access. Meanwhile, VNet peering simply connects networks. It helps with connectivity, not access control. Similarly, Azure Blob Storage is about storing unstructured data like documents or media. It doesn't manage identity-based security. Lastly, Azure Cost Management focuses on budgeting and usage tracking, which has nothing to do with enforcing access policies or Zero Trust. So in a real-world environment where you're trying to protect sensitive apps and data, Microsoft Entra ID with conditional access is your go-to for enforcing Zero Trust security. Arrange the following steps in the correct order for configuring Azure Monitor alerts for CPU usage threshold on a virtual machine. 1. Select the resource to monitor, virtual machine. 2. Define the alert condition, CPU usage threshold. 3. Create an action group for notifications or actions. 4. Assign the action group to the alert rule. 5. Set the notification type, SMS, email, or webhook. 6. Review and create the alert rule Alifros. Now let's walk through each step in the right order and explain why they matter. We start by selecting the resource to monitor. This is usually a virtual machine, as it's the asset we want to observe. Once that's set, the next step is defining the alert condition. For instance, you might want to trigger an alert if CPU usage goes above 80% for more than 5 minutes. Then we create an action group. Think of this as the response team. It defines who gets notified and how. After setting up that group, we assign it to the alert rule to link the condition with the response. Next, we configure how we want to be notified. This could be through SMS, email, or even an automated webhook to trigger another process. Finally, we review all the details to make sure the configuration is accurate, then create the alert. Each step builds logically on the previous one, ensuring that alerts are triggered appropriately and the right people or systems are informed in real time. You need to review the root cause analysis RCA report for a service outage that occurred last week. Where should you look for the report? Select only one answer. A. Azure Advisor. B. Azure Monitor. C. Azure Service Health. D. Log Analytics. The correct answer is C. Azure Service Health. Now let me explain why this is the best choice. Azure Service Health is the official service that notifies you about ongoing or past issues with Azure services. It also provides detailed incident reports, including root cause analysis after the outage is resolved. This is especially helpful for sharing with stakeholders or for audit purposes. Meanwhile, Azure Advisor focuses on performance and cost optimization recommendations. It doesn't deal with outages or incident reporting. Azure Monitor is useful for tracking real-time metrics and logs, but it doesn't produce official RCA reports. And Log Analytics is great for querying logs, but again, it won't provide the official post-incident analysis you're looking for. So when it comes to tracking down what went wrong in a past outage and reviewing a formal RCA, Azure Service Health is the right tool.